thank you all for coming. Really appreciate the time you're going to take and spend together for the next 90 minutes. My name is Mark Pollack. I'm the lead of the Spring Data family of projects. Beside me I have Michael Hunger on the far side there from Neo Technologies, and my colleague John Brisbin. And they'll be talking to you later in the presentation about some of the areas of Spring Data that they focus on, namely Neo4j, as you can tell given his t-shirt, and I guess Rabbit given your t-shirt, but no, it's not Rabbit, it's going to be the Spring Data REST exporters. So what I'd like to do is again do those little fun statistics about how interesting the data landscape is, and hopefully set the tone for why we're doing this project, the Spring Data. Elaborate on those goals, and then go into a tour. I chose to kind of focus on some of the technologies that don't have dedicated sessions here to give a little bit more well-roundedness to it. And we'll be diving into about 4 projects, 4 or 5. So you saw some of this yesterday in the keynote, the trends in data in terms of the size of the data that we have being stored. Right now it's around 1.3 in 2012 exabytes of data, and it's just getting larger and larger. Sort of one fun statistic here is on the right, namely if you have 1 exabytes of data, then that's about as many bits in the digital universe as there are stars in the physical universe. So quite a lot of information. And if you want to see more about these kind of infographics and actually a very long report that kind of covers the landscape, IDC is a company, marketing company, survey company that does these reports on behalf of EMC each year, and they have reports going back to 2009. You could check it out. Obviously, a lot of that data, you probably think it's DVD files or stuff like that floating around the internet on BitTorrent. But the enterprise actually houses a lot of this data. This is a more detailed slide showing that across different sectors in the U.S. economy, where 15 out of 17 of them have more data than the Library of Congress. And that red line there is essentially the size, around 300 terabytes of data for each firm in each sector. So you can see some of them, like securities and investments, are like way, way off to the right there, right? Very, very high usage of data. And what is generally being stored here in the enterprise, as you imagine, for some areas it might be video and image, but generally speaking this is a heat map. Darker blue indicates, you know, more frequent use. It's text and numbers basically, lots and lots of just raw streaming data, not so much multimedia. And the nature of this data is important. It's largely unstructured, meaning that it's not known what you want to do with this up front in terms of assigning a schema up front, much like you do with a relational database. And as such, it doesn't really fit very well with deciding to make a schema in a database. So that's one of the motivations there are to move to alternative data stores. Another interesting aspect of how this data gets used is pre-aggregated data. So as data is collected, it's often interesting to collect information about it. These are things such as counters or running averages, almost sort of like monitoring type use case. The other trend, in addition to the size, is around cost. The cost of disk is dropping, about a sixth of it, a sixth the cost of what it was in 2005. And as well, no one is really going out and buying these big honking sun boxes anymore. I remember I used to have a nice fridge box of SGI, and you can kind of plug them in, and then Cray bought SGI, and you could like plug them into even bigger and bigger things. People don't do that anymore. Basically, you have rows and rows of commodity servers with huge switches on the top, and it's a lot cheaper. So essentially 1K per CPU for a typical data center cost. But the real value and what motivates people is the information that they can gain to improve their business processes as a result of analyzing the data. And this is really where all the sort of reason for the investment in these technologies is coming from. So the trends of the future around people who specialize in doing statistics, so-called data scientists now, they used to be called statisticians, I guess, is going to be an increasing part of the landscape for big data going forward. There's really a shortage of people who are trained to handle this type of task. And there's great value in not just collecting one stream of data, but collecting many sources of data and then connecting them. One sort of interesting fact was there was in the mainstream media a report about how Orbitz was grouping together people who use Macs, basically, and realized that people who use Macs will tend to actually buy more expensive hotels if you show them more expensive hotels. So all you people here with the Macs, you think you're so clever? No. Anyway, I got this clunky old thing. Yeah, so it's kind of interesting. Every so often something comes up in the news around how a large company has gained apparently significant amounts of revenue because of some analysis that they've done on the data they're collecting about your activities. And there's a reason, Facebook, for example, LinkedIn are drivers of some of this new technology because they're the ones that want to store it and collect it and figure out how they can make money off of that data. A lot of interesting moral questions there, but we won't get into that. So what's happening is that not only is the unstructured nature of the data, basically the format of the data changing, it's very difficult to really scale a relational database. Vertical scaling is hard, and the same thing with horizontal scaling. And as a result, the idea is that a general shift for these systems to move away from the ACID semantics you're used to in a relational database to so-called BASE acronym, meaning basically available, scalable, usually they're in clusters, and eventually consistent. So if it's in a cluster, you might not necessarily get the same data you asked for if you hit different servers. You might have to take that explicitly into account. And there are ranges, so this is kind of just a rule of thumb here. Neo4j is a transactional database, for example, but there is a shift away from that. And as I mentioned before, with Facebook and LinkedIn, really NoSQL databases and big data technologies are emerging out of industry primarily. The Amazon Dynamo paper, the Google paper on Bigtable, these and Google's paper on GFS, a distributed file system, which led to Hadoop's file system. These are all sort of the drivers behind it that they needed to invent this technology in order to satisfy their business requirements. And we're sort of the beneficiaries now of a lot of that work. So NoSQL is not only SQL, and it basically describes this trend where we're increasingly looking for non-relational databases to help solve our problems. It doesn't mean you should not use relational databases, but you should look to other options based on the use case at hand. It also doesn't mean you can't query it, right? It's sort of one of these funny acronyms that people in retrospect would have liked to have been something different. So there are loads of query mechanisms in NoSQL databases, some easier than others. Key lookup, not quite really a query, obviously. MapReduce gets poked fun at, probably rightfully so, because it's a bit difficult to use as a general query mechanism. But more and more of these NoSQL stores are having more sophisticated query languages or query by example semantics to make it easier for you to get data out. Big data is a sort of oblique term. It's just generally considered to be sets of data that really go beyond the range of a typical, meaning relational database to store. It's a subjective target based on the amount of data that is sort of currently considered big at the moment. As you saw in the beginning of the presentation, that graph is increasing, doubling every year, or every 2 years. So right now, if you look at the sectors, at least in the U.S. economy from that survey, basically you can say if you have tens of gigabytes to multiple petabytes of data, you're sort of in the big data camp. And NoSQL and big data kind of overlap in that regard. But there's a reality check. I just did a quick Indeed Trends search. I did MySQL, Oracle, and then NoSQL, and this is the absolute scale of jobs that reference it. You can type in a whole bunch of other things, but you can see the standard curve of Oracle relational database is much higher. So they're not going anywhere, and it's for that reason that in the Spring Data project we've revived the support around relational databases that Spring has been well known for in the past, because everyone is still using it day to day. In fact, that is the most popular Spring Data project, is the Spring Data JPA project from our measuring of the download statistics. So yeah, NoSQL isn't never SQL, it's a combination. Another reality check is here's the relative scale. A lot more people are interested in NoSQL going forward, right? So it's important for us to get this technology on our proverbial developer's tool chest and understand how we can effectively use it going forward. So that landscape sort of sets the tone for the goals. The Spring Data project was started 3 years ago when started to see this change in the data landscape. As I said, the relational databases are still important and predominant, but it's no longer a one-size-fits-all situation. And of course, Spring has always provided excellent data support, from transaction management abstractions to resource management, JPA, JDO, JDBC. All of these are sort of mainstay features of the Spring framework. Even most recently, in terms of the caching abstraction that you saw Jürgen mention in the keynote, these are all traditional parts of the Spring framework. And our goal was to refresh Spring's data support, both relational and non-relational. And so the mission statement is to provide a familiar and consistent Spring-based programming model for Spring for big data, NoSQL, and relational stores, while retaining store-specific features and capabilities. And the feedback I got last night after the keynote indicated that I really need to emphasize this point, right? People are used to Spring abstracting everything and coming up with the lowest common denominator. While there are some features in the Spring Data projects, notably the repositories that do provide some portability, you are always able to get at the features of each specific database, which is often why you probably picked it in the first place, like incrementing counters or doing MapReduce. And so just to make the point even more clear, right? Store-specific features. If you love Mongo and you sleep and dream Mongo, you can use Mongo template to your heart's content and access all the functionality there is in Mongo. So this is the range of technologies that we support actively. In the relational space, it's JPA and it's a JDBC extensions project as well. In NoSQL, Redis, Mongo. HBase we just started a little bit of support. It's not as feature-rich as the others, but we have some. Neo4j, Gemfire, and there's a nice community contribution around Lucene. Cray DSL is not a project we develop, but we integrate very closely with it. It's a separate open source project that provides a type-safe DSL for executing queries. Big data. This revolves primarily around Hadoop. There's many products in the Hadoop ecosystem. HDFS is the storage layer. MapReduce is the computation engine. So those are kind of the bread and butter of Hadoop. And then there are higher level programming languages you can use to analyze the data that you stored inside of HDFS. And these go by the crazy names of Hive, Pig, and Cascading. I'm sure there's even worse names out there. And also, recently, we've started to look at Splunk as well in the big data category. And the last part here, what John will be talking about, is around how do you get access, primarily over HTTP, to this data. So we were trying to make it easier, in particular for browser-based communication, to get access to this data in a standardized way. So this is sort of the breakdown of where you have database functionality that's specific to a store and functionality that's common or shared. So much like JDBC template was the place to go for all the JDBC goodness, anything you want to do that's very specific to the database, you go to one of the template classes. So Redis template, HBase template, Mongo template, Neo4j, Gemfire. Those are the places you'd go to get database-specific functionality. The repository model, meaning data access layer repository, is where there's some shared common CRUD functionality across the data stores. Much like you always had an escape hatch in the template classes with a callback to get at the underlying resource, here there are also customizations that are, or you can get at the lower level APIs or lower level functionality of the data stores, so you're never locked into a lowest common denominator situation. And for the repository model, and as well as with, I didn't put Query DSL JDBC template, forgot that one. But we integrate with Query DSL basically wherever we can. I'll show an example of that technology as we go forward. Yeah?
I just saw that Riot and block support is out of Spring Data.
Yeah, so the question was, on the website there's an attic, and it says, I see that React and Blob Store were moved out of Spring Data. So yeah, actually John had started on the React support, but we never had enough really time to fully devote to it. And I started the Blob stuff as I was teaching a class at NYU and hoped the students would actually do all the work, and that didn't really work out too well. Bad teacher. So that's the status of those projects. There's no roadmap now. Actually, one of the things I would really love is for you guys to tackle me in the hallway or any of the other guys you see on the data team and give us information about what it is you would like to see. I was thinking to do a survey, monkey survey, get some information from you folks. Yeah, that's on the list. Cassandra's on the list, right? HBase is on the list. You know, you got to pick and choose, right? And so we have to.
It is a good project for Spring integration for cache reader or using Hector.
Yeah, yeah. They all have valid cases, right? So we can talk afterwards. Thank you.
I'd like to know more about blob support, but offline.
Okay, we'll get back to blob support another time. So here's a project tour. I'll start off with repositories and JPA and then move into more of the NoSQL stores. So I think we all know what repositories are essentially. It's your data access layer. Martin Fowler is classic at putting things in great diagrams and giving them very good academic definitions. And so this is just a mapping between your data source, not necessarily a relational data source, and your domain model. And Spring Data repositories make it very easy to remove the busy work of creating a repository. There are a few recipes that are common if you're using Spring Data repositories, but the most basic one is go to your POJO and add your mapping annotations. In the case of JPA, use JPA annotations. Then you can extend one of the Spring repository interfaces for CRUD, and then start adding finder methods as needed in order to get specialized queries. And we'll show this in a minute. And that's it. You really didn't write any code in the sense, nothing inside curly braces really except an interface definition. And now you configure Spring to scan for these interfaces, and it will automatically create a repository for you, which you can then inject into your service layer, for example. So this is the functionality you get in Spring's CRUD repository. So you have save, find one, exist, find all, count, and a few variations on delete. So very basic create, update, delete functionality. There's another repository interface, paging and sorting repository. A lot of pain seems to go into people writing code that does paging and sorting. So here we have a pageable class, a sortable class that captures that domain and lets you use it very easily simply by implementing this interface and getting access to the method findAll, where you can pass in sort criteria or pageable criteria. So here's an example using a fictional person repository that takes a person. And now I show you these custom finders. So it's a name-based convention. You've probably seen it in Ruby 6 years ago. So yeah, we're just catching up. And I'll have a finder called find by email address. And what this is assuming is that there's a Java Bean property on the person object with the name email address. Similarly for the next one, find by last name like. Now here like is another keyword which you can use to do star matching on the string. And there's a whole variation of these. You can also combine it with paging and sorting. So here's an example using a fictional person repository that takes a person. And now I show you these custom finders. So it's a name-based convention. You've probably seen it in Ruby 6 years ago. So yeah, we're just catching up. And there's a whole variation of these. You can also combine it with paging and sorting. So here's a laundry list, in this case with a translation table to JPQL, where if you have a keyword where you want to join two Java Bean properties together, namely find by last name and first name, if you had to use that inside of JPA, you'd be typing that string. So I think you can kind of get the general gist of how this translates. And what you'll see in a moment, there's also integration in the IDE that you can get code completion off of your domain model or little red squigglies in case you make a typo in the method name. And it doesn't match one of the properties that are on the domain object. So just a few words about Query DSL, and then I'll jump into a small demo that shows this in action. Query DSL allows you to have type-safe SQL-like queries, and it supports multiple backends. So it includes JPA, JDO, plain SQL, as well as non-SQL stores like Mongo and also Neo. And I spent a long time working in .NET and was exposed to LINQ, language-integrated query functionality in .NET, which this sort of comes the closest in the .NET, in the Java community. So basically you write code, which is queries, and you get very nice completion. And if it compiles, you're sure that it's going to work. There's no sort of strings anymore that make the contract more loose. So it's quite nice. So yeah, almost no syntactical invalid queries are allowed because it's a domain-specific language. It's generated actually using the code generation, the annotation post-processor in the Java compiler. So there is that kind of extra build step, which isn't wonderful, but I think the benefits outweigh the cost there. In particular, if you're just using JPA, JPA2, and you do a side-by-side comparison of the criteria API versus Query DSL, you'll see that Query DSL is much shorter. They have these query objects that get generated, the queue customer, and then you create a query, and from this you can say, I'd like to select from the customer where customer dot, and that'll literally come up in your IDE, first name, the property, and then operations, and you can chain all these things together. So it's quite nice. So Query DSL repositories, the condition, customer.name equals, Bob, is the type predicate in Query DSL. And so you can pass in a predicate expression to these finder methods. And then to access that, you just have your repository extend. Here I'm showing an old slide, JPA repository. Really it would be CRUD repository and then Query DSL repository. So I'm going to jump into a small little tour of this. I'm not going to go very deep. To go very deep, there's another session by Oliver Gehrke, who will go very deep into the repository implementations. This is a typical example. This comes from the book we wrote, where you have a product that has line items, and customers have address and orders and so on. So I just reset my entire thing. I have to bear with me while I organize myself. So here we can just walk through very quickly how this entire thing is bootstrapped. I should probably set the size. So this is bootstrapping, oops, sorry, the, is that what I wanted to show you? Here we go. You define the data source, over there, data source. In this case, we're using embedded database. Here we're bootstrapping Hibernate, and here we define our transaction manager. To to use the repositories, then we could in turn import that class, and then use this enable JPA repositories, which will indicate to Spring, when it's processing this configuration class, to scan for all components that have the repository annotation on them. As an example of the repository annotation being used, where is it? Oh, actually, in this case, I was using a marker interface. So if you go to CRUD interface and sorry, product. Yeah, I don't know why we didn't put one there. Anyway, this extends CRUD repository and Query DSL predicate executor for product. I'll show you product in a moment. So CRUD repository means we get all of these methods I showed you earlier: save, find one, exists, find all, and so on. And here I have find by description containing. So a product, as you'll see, contains a name, it contains a description, it contains a price, and it contains a pair of attributes that describe the product. So here I'm going to find something where the description contains whatever I pass into the method, and I'd like the results to be pageable. What's nice is if I say description, it's going to say, invalid query, no property description found for blah, 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 blah. Similarly, if you were to go here and say page product, find by, oops, you can say name, and you get the completion. You say string, name, you say and, oops, not happy. Oops, I should complete that. Something's wrong. Well, you get the general idea. Hopefully it won't bomb and you're doing it. Similarly here we have a find, but in this case we've overridden the query that would have been inferred from the method name, and now we're supplying it explicitly inside the annotation. You can also externalize this query outside the class code itself. If you take a look for this simple thing in action, what's this doing? Oops. There is a small loader for this, and you see we love our iPads and MacBook Pros and docks for products. And so here I create a new page request, and I'm looking for items that have Apple in them. If I run this, you get a little green bar. And this code is available in GitHub, associated with the Spring Data book that was released this week. Yeah, question? No, the client defines, well, you mean like a web client? So the question is, who defines this page request? I mean, it's like you see here. Obviously, we often connect it to a web client, and there is actually, in the Commons project, some JSP tags to help glue the two layers together. Yeah. The other thing I'd like to quickly show here is Query DSL. So here, this is a class that's generated by Query DSL, code generator. And here you see I'm saying repository find one, and this is the predicate expression, product.name.equals. And here you could like tack on, dot and, whoops, caps lock, product dot price greater than 10, right? And so now this is compiled, and off you go. And you can kind of build this whole thing up as you go. And what's really nice, even in some sense slightly better than LINQ, is that, for example, this will have aggregate queries, like group by and stuff like that. But if it's applying to a NoSQL store that doesn't have those operations, then those methods aren't generated, which, unlike LINQ, was very SQL-like in its nature, and so it actually has operations on it that don't really apply sometimes to certain data stores. So there's that, and I think that's all I wanted to show here. Oh, the other thing I wanted to show very briefly was that you don't necessarily have to extend CRUD repository. You can use this or an annotation. This is just like a marker annotation. And now, instead of having all of the methods like save, update, delete, maybe you only want to expose a few things, like one save method and one finder, find one. So as long as you sort of duck type correctly and say, I'm going to write the method name in this interface exactly like it is in the CRUD repository interface, we'll match up the signature and create the appropriate implementation under the covers. So you can just sprinkle around the few methods you want. So it's not mixins, really. It's just sort of a poor man's way of getting this convention-based functionality instead of something more statically typed. Okay. Let me go back to this.
Question.
Yeah, question?
Is there any implementation in future, just like you have the dedication concept for JPA? Is there something can be done at the JDBC template level as well?
So the question is, can Pageable be done at the JDBC template level as well? I don't see why not. We have some even Cray DSL integration with JDBC template, but we don't have repository support for JDBC, for example. Okay. Right.
But we can still do that with Cray DSL.
The question is, can you still do that with Cray DSL, with Pageable? I don't remember if there's Pageable support in Cray DSL. There might be. I'd have to check. No, so this is, well, if you have the, so the question was when you're using paging, you're using the Hibernate L2 cache. I mean, the cache configuration is separate from how the query is being resolved is separate from the infrastructure of paging. So paging is just collecting the necessary information to tack on to the query that's sent down into the database, and however the database is configured, it'll return the answer either more efficiently in the case of an L2 cache or not. Right? So I think they're separate concerns. Yeah, question? Does it support joins? Yeah, so in the case of doing regular SQL, and of course in the case of doing JPA, you have joins, left joins, right joins for JDBC, all of that. Yeah, so we're not doing, so for example, the question is around resource management, around Pageable. We're just calling into the database, right, more efficiently. So it's really what we've done, right, if you look at this class, this is what you would have coded up by hand, right? Find one, entity manager persist, type query, blah, blah, blah. We're just automating, essentially, this code that you don't have to write. We're not doing some deep magic around, Gemfire is one of the repositories I support. It doesn't support paging, and we explicitly don't make something that's on top of the database because that's really the job of the database to do paging. Okay. Am I on time? Oops. So I'm going to go through about two, maybe three data models, and then I'll have time to hand it over to John and Michael. The basic family of data models that is settled on in the NoSQL taxonomy are key value. This one to the right of the key there is called the column family or column stores. Essentially it's key value, but the value itself is a collection of key value pairs. So if you look at B, that's the key, and then you have column A, column value, and then column B, colon value, and so on. It takes a little time to wrap your head around it, but it's sort of like nested hash maps, essentially. Document data stores, usually JSON focused, and then graph databases where you have lots of interconnections and directed graphs and properties. So I'll show a little bit of functionality for a few of these. Redis is a key value store. Its most popular cousin, I suppose, is Memcache, which has been in use for quite a lot, usually for accelerating serving up web content. What's different here is that the values aren't necessarily simple strings, but there are a lot of rich data structure types. So it's almost like what should pop into your mind is like Venn diagrams. I can have sets, and I can make unions of sets. I can do intersections of sets and lists and hash maps and so on. And you can operate on them doing simple things such as adding or incrementing a counter, or the union intersection operations I was talking about. Much like Memcached, it has a very fast performance profile in terms of operations you can do per second. And its persistent story is it takes periodic snapshots of memory and puts it into a log file. It's not yet clustered, so there are limitations in how you can use this. People like Twitter, or companies like Twitter, have actually sharded Redis, and so I think all of the recent timeline for every tweet is in some enormous array of Redis clusters with some homegrown sharding, because they very much like the quick access that it gives for retrieving data. So Spring Data Redis, one of the key things it does here is there are several drivers out there for Redis. About 3, I think, when we started. Now there are 4. And so we provide a common API across all of those drivers. So if one driver kind of dies out in sort of its development, you can always swap in another one that might take its place. So it's sort of a de facto API. Redis template is how you get access to all the functionality there is in Redis. There are descriptive method names that are grouped into categories. So you have ops for list, operations for hash, and so on. And if you look at the Redis documentation, you'll see there's quite a lot of functionality. I can pop that up in a minute. The Java util collection classes, things like atomic long. You can now create an atomic long instance that's backed by Redis, so you can use a familiar API for doing your counting, but have it be persistent. And also Redis is an interesting thing. It actually has publish subscribe functionality, much like you might associate with Rabbit or JMS. And so we've made an analog to Spring's message listener container that's in JMS and Rabbit, so you can consume data from Redis, event data, and still have them dispatched to POJOs, methods on POJOs. So I'll do a very quick tour of that. You saw a little bit of this yesterday in the keynote. Where is Redis? So here's an example where using Redis atomic long, and I'm incrementing. This is the name of the key. This is a long name, Spring Data Book. And now I have basically, I could probably make that just atomic long. No? And just call it increment. So if I go here, no. Where is it? All right, so no keys. Run this. Similarly, the slightly more interesting one is this, where I create a Redis template, and here I parameterize it by the key and value pairs that are most commonly going to be used. In this case, I want to do counting, so I have a string for the key name and a long for the value. There's some little work you have to do to set up how things are serialized, a long serializer and a string serializer. Now they can get ops for value, right? This returns value operations. And value operations are basically around counting. So you'll have append, increment, multi-get, multi-set, multi-set if absent, set if absent, and so on. Basically all one-to-one with the Redis commands. So here I have ops set if absent, set it to 1, and then increment. If I run this guy, and then go here, whoops. It should be 2, because I set it to 1 if it was absent, then I incremented it. Oh, I don't want to bother with that now then. I was going to show you the variety of commands that there are. Okay, so now I'll move quickly on to HBase. HBase is a column-oriented database. Basically, a row points to columns, which are actually key-value pairs. And what's important is that these columns get grouped together. So collections of key values get grouped together into something called a column family. And this is sort of the unit by which things are persisted and moved in and out of disk. So that, for example, if you have a customer object, you might segment some parts of the customer object into one column family that are frequently accessed together, and other properties of the customer that aren't accessed together. This way, when you read it from disk, you're most frequently doing I/O only on the parts of data that matter to you. The data is stored in HDFS, and it's generally modeled after Google's big table. You do need to define a schema up front of these column families, so you have to define these groupings. But the individual key value pairs you put in the column families is up to you at runtime. So it's sort of an in-between schema and no schema. You have to decide a little bit of stuff up front, but you still have a lot of flexibility going forward. And its legacy, here, as you can see, a big table is its intention was to store, billions of rows in a table. Here's a little example of how you would use it. They have a shell. And so here I create users, and those first 2 curly braces define column families. So column family info and column family status. And now I start adding key value pairs into column family info. In this case, I'm adding a user, an email, and a password into the column family info. And I'm adding email validation Boolean flag into the column family status. So the idea being that I'll frequently get the user, email, and password, but not frequently access the email. Then you can print it out, and there's inherently a timestamp associated with it. There's a lot of sorting rules that revolve around timestamp, which we won't get into. And this is the native API. Basically, you create a configuration object, in this case a Hadoop configuration object. You get reference to an API object called htable, and you can see there are a lot of bytes to bytes and stuff like that where you start adding to a put operation and say table put this data into HBase. So what Spring support for HBase does is it bootstraps the configuration, and HBase template provides resource management in the sense that htable is not a thread-safe object. So you'd always need to create a new one and close it in order to use it in sort of any real-world scenario. So much like other template classes in Spring, it does resource management, exception translation, and we've mimicked as a first step the lightweight object mapping that's available in JDBC template, namely row mapper, results extractor, and then you have the lower level callback, which gives you access to an htable that's properly managed in terms of its life cycle. Oops, typo. So here's a simple application context for bootstrapping this. I use a Hadoop configuration to point to Hadoop's name node, which is how you get started. There's a separate configuration step for HBase, which we've encapsulated in a namespace. And then I instantiate an HBase template. And then there's a simple app I would walk through very briefly. So user utils does some basic housekeeping around tables, and adds one column family called cf-info programmatically. I had showed that in the shell before, but you can also do it programmatically. And then I create a table. Then I call this utility class add users. And there's user repository save, right? And here I'm using HBase template execute, right? And I'm just now putting these native API calls inside of anonymous in a class so that the resource management around htable is done correctly and exception translation is done into Spring's DAO hierarchy. So I create a bunch of users. And then the nice stuff is, for example, find all. I'm going to now look for all of them. And I do HBase table find. I give it the table name, the column family name, and I specify here a row mapper, much like you did with JDBC. And for each result in the result set, I parse out the information and create a new domain object, in this case, user. And I just print them out. Oops, not a Java. It is a Java app. I'm deleting the users. Done. Then I created users, and there they are, user 1, 2, 3, 4, 5, and so on. So how much time do I have left? No, for the whole thing? Okay, I'm going to whip through Mongo and then go off to Neo. So there was already a talk today on Mongo. Mongo is a document database. It's a rich set of functionality. Documents are organized in collections. There's a rich query language. It also has MapReduce functionality, which is helpful in doing aggregation queries. And there's recent improvements there, so you can actually use a new aggregation framework that they've built instead of dropping all the way down to MapReduce. It also supports an architecture where you can have replication, but also sharding, so that automatically sharding your data sets and shuffling it around when there are imbalances and so on when servers come and go. So Spring DataMongo adds Mongo template. There's a fluent query, criteria, and update APIs. I'll show it very briefly. Again, translation to Spring's exception hierarchy. A dedicated template for GridFS, which is a way to store files inside of Mongo. There's the repository support, which you saw during the keynote, the Cray DSL integration. There's a feature a lot of people asked for that no one's using, which is cross-store persistence, namely that you can have, let's say, a JPA annotated object, and then one of those fields will have an @document annotation on it, and when it's stored in the lifecycle of JPA, it also stores that one field or many fields that have a document annotation into Mongo, and then the reverse happens when you store it. So there's a lot of deep aspect J magic going on there. It's cool. It's great for water cooler conversation. Maybe people just don't know about it, but that's what I mean by cross-store persistence. Here's just a brief look at Mongo operations. You see the typical flavor of having execute operations that give you access to the lowest level of the API, namely the collection or the database. Those are the APIs in Mongo itself. Find methods, save methods, update first, and then Mongo supports geolocation queries, so there's a geoneer, and then we have a bunch of features around that. So here's a simple walkthrough. I won't go through it in the IDE. You create a new Mongo template. Here I'm creating a person object, and then I'm saying insert person. This is actually doing some object mapping. I'm doing find by ID next. I'm doing update, and here you see the fluent syntax with some static imports. Query where name is Joe, and then I'd like to update it. Update just that one field in the document, his age, to make him 35. What I don't show here are operations around MapReduce and operations about counters, incrementing, but they are there in the Mongo template. These are the annotations. Document is the annotation you use to indicate that you'd like to map this object into Mongo. ID indicates which is the ID. There's some auto detection. These are actually optional. You can create indices. And for me, actually, the moment when I realized that you couldn't make a lowest common denominator set of annotations was around index. I think it was me, Oliver, maybe Michael on the phone, and we each brought up the index annotation for JPA, Mongo, and Neo4j respectively, and there was absolutely zero overlap, except for the default case with no arguments. So you could tell it to index something, but not tell it to index it in any specific way that was relevant for each data store. So that was an interesting turning point. Field, there's customization, how you can tell what key to use. Often we'll just use the name of the field, but you might not want to use the name of the field. That's sort of an internal detail. And probably most importantly, dbref, you can point to other objects that are in other collections inside of Mongo. And Mongo repositories, it's really just the same as you saw with JPA. You can get at functionality that's Mongo specific, such as geolocation, and then you can also have the query language expressed here in terms of JSON instead of the JPA QL. So I'm not going to have time to do this code tour. So now I'll pass it over to Michael, who will talk a bit about the Spring Data Neo4j project. Do you want to come up here?
I can also sit there.
Yeah, man, sure. Come up, maybe.
I can.
Okay.
Can you hear me? Okay, cool. I just have to look for the setup. So let's see. Okay. Going. Okay, cool. So I want to talk about Spring Data Neo4j, which is actually one of the the founding project of the Spring Data project. So I'm working in lots of areas at Neo, and one of these areas that you can see down there is the Spring integration, which has been lots of fun working with Mark and Oliver and John over the years now. So I will just extend Mark's explanation about NoSQL stores by one dimension. So you know that he spoke about the volume problem, data volume growing all the time. And there's a second dimension, that's complexity, data complexity. So as you know, there's lots of data out there that is easily handled by key value stores and column family and document stores. But if you look at more complex data, be it the social network data, or be it data from ERP systems, or data from master data management, or geodata also, and even if you combine all these dimensions or these different aspects, then you're getting into complex interconnected data. And the interconnected data is actually handled pretty well by relational databases, but there are still some issues with them. So that's where graph databases like Neo4j come in. The major issue is the join and modeling problem with relational databases and connected data. Interestingly, even if the data size does not go into the penta and exabytes that these stores handle, it's still that 90% of all use cases are easily handled by those. So not everyone has the Twitter or Google or Facebook problem after all. Just a quick recap, what are graphs? We're not talking about graphs when we mean charts, actually, right? And not vector artwork, but it's storing connected data as graph data in a database. So like, you certainly remember linked lists, trees, and other similar structures. And graphs are actually the general purpose structure for these connected things. So usually use relational databases when asking global queries, right? Give you the average age of everyone in the room and so on. A graph database would rather be used to tell you something, who's most likely to buy your beer after the session, right? So it's these kind of recommendation algorithms and stuff like that. It's easily handled by the graph database. And actually it was quite interesting for me when I get started with the whole thing that actually if you look in the real world, graphs are everywhere. people are connected, things are connected. It's products, orders, authors, books. In the sciences, you have proteins, DNA fragments. In chemistry, you have reactions. If you look into politics, like for the election data, we did a federal election campaign data thing with graph databases. Was very interesting. History is connected to politics. In business, we have lots of different places where connected data rules. And of course, we all know that the internet is one huge connected graph after all, and all the stuff that's happening in there. So no matter where you look, it's always connected data everywhere. And it's not so easy to handle this kind of data without dumping it down as of now. So you had to leave off relationships because they didn't fit your model and so on. So actually everyone talks about graphs. So we have the Google Knowledge Graph, Facebook Overview Graph, Twitter Interest Graph, Bing got stuff to work with their graphs. And our graph database is actually popping up every other week. So we have from all minor major vendors, there are graph databases. And Neo has been actually been around for 10 years now and got public in 2007. Graph databases. So actually that's a graph from LinkedIn. There's a LinkedIn Labs project that can render your personal graph of connections. So I encourage everyone to go there and check it out. It's interesting which clusters built up there. So that's my personal graph on LinkedIn. Just search for LinkedIn Labs. InMap is the URL. So of course you all know relational stores, right? We have two tables. One is foo and the other one is the bar table. And there's something in the middle to connect them, right? Let's call it foo bar. So we have the foo element, the foo column. We have the foo bar rows in the middle, and then we have, of course, bar rows in the bar table. And we always have for M-to-N relationships, we have to introduce a table in the middle, which is oftentimes very costly in terms of modeling and performance. If you look at graph databases, it looks different, but models the same aspect. So we have our elements, are all these blocks there, and then we have actually real connections between these elements, right? And those elements, we can find the foo object, the foo element, and the relationships, the yellow ones, and the bar elements as well. So it models the same data, but in a much more natural way, because relationships are a first-level citizen in a graph database. And in a graph database like Neo4j, it's a property graph, so we have nodes and relationships, as I said. And both nodes and relationships can have arbitrary number of properties. So Neo4j says a NoSQL database, it's schema-free, so you're not constrained by any kind of schema. Something very important about graph databases is that relationships are actually part of the data, not part of the schema, but part of the data. So as easily changeable as setting a name on an element is also to add a new relationship to some other element. You can query that also with a query language that we developed. It's called Cypher, and it has special support for matching relationships in the graph, as you can see in the match clause. So we have a user who sent a tweet, and the tweet is tagged with a hashtag in the tweet as well. So that would show you something like that. Follows two steps into the graph starting by this node. Graphs are also very whiteboard friendly, so actually what we encourage our users and community members to do is just grab a whiteboard, grab some colleagues, draw your domain as you would like to have it or as it is in the real world, and then just put this data in the graph. Don't kind of dump it down, don't leave stuff off, just put it in there as it is, because then you can ask the interesting questions and get also the interesting answers there. So we can do it on an abstract level, that's users, tweets, and tags, but we can also do it as the concrete level, that's tweets, people, and mentions, and tags, which is the same as the abstract thing, but that's what's in the database. Neo4j itself, it's a JVM-based database, so we wrote it on our own. It's not running on top of some other database, but it's a real database engine. It has binding for lots of languages on the JVM as embedded database, so it's really nice to use on the JVM like you would use HSQL, but it's also available as a server. And it scales pretty well right now for read operations, and for write operations, we're working on graph sharding right now. And it has, as Mark already said, transactional support. So it's fully transactional database because the graph model, as you can also see there, it's a fine-grained model of nodes and relationships, and if you don't have transactions, you end up with half-applied updates and changes in the database. It's different to many other NoSQL databases which have an aggregate element and only operations inside that aggregate are atomic, but cross-aggregate operation like dbrefs are not atomic within an operation. I already showed the query language. It's called Sulfur, and also allows you to do filtering and aggregation and ordering and all this stuff. So it's really nice to use. And actually what we did was also additionally, we just wrote a JDBC driver for that, which just takes the query string and returns tabular results, but talks to a graph database at the end and not a relational database, which is a nice solution for BI and similar stuff. So that's the picture you already saw yesterday in the keynote. Mark showed it. And here we see how the data that I just showed as the kind of whiteboard thing looks in the graph, right? I just chose 4 tweets, and people sending those tweets, the text these tweets are attached to. And if you have this data in the graph, you can start to ask interesting questions. How did I get it into that? So I just use Spring Data Neo4j for it. I have a very simple domain model of tweets, tags, and users, and I annotate an entity with node entity and give it a unique primary key. And then I add a simple text field, which is just stored directly into the graph. And then down there you see the user, the tags, the mentions, and the source tweet for retweets, which are also entities. So in the graph, they will be represented as relationships to other nodes. So just something like that. And then I just pull the data from either Spring Social or from some source like a JSON file, put it into the graph, and then it looks like that. I just use the repository to save the stuff, and I can also use the repository for query the things as well. And one interesting query would look like that. So I just check which people tweeted about Obama and Romney at the same time, and then how many of those tweets did occur. And then we see the kind of the tags on both sides and the counts as the result. So that's a very simple query and kind of lets you kind of think about the power that's behind this densely connected structure. So as I already showed in Spring Data Neo4j, no, I didn't show it. Spring Data Neo4j is, as Mark said, one of the Spring Data project, and it's a brainchild of actually from Rod and Emil, who got together coding and started with this project. And we spent a lot of time building upon their initial prototype. That's about it, what I wanted to say. Thanks.
Okay, next we'll have...
Cool. That was quite fast.
How much time we got?
You have...
Everybody see that okay, or do we need to... What's that? See if that's better? A little better? Okay. So as Mark said, I'm John Brisbin. I've worked on the Spring Data team for a while now, and the project that I've been focusing on for, I don't know, 9 months, something like that, that I'm going to be presenting on Thursday is Spring Data REST. Spring Data REST is, basically taking the JPA repositories that Mark has shown and that you've kind of seen examples of, and exporting those to a RESTful web service without you having to write any code. And you literally don't have to write any code to do it. You have your repositories, you set up the proper configuration, and then they're exported to a RESTful web service. We'll come back to that. That's the book. And it's real quick, just as a reminder, Spring Data repositories take a lot of the drudgery out of just writing your normal CRUD applications. They handle your JPQL queries if you want to get anything very complicated, or you can use the default finder type mechanism. If you ever use Grails and you type finders, find by customer, all that easy parsing of the method name to do that for you automatically. The Spring Data repositories, we have JPA and MongoDB, of course. The Spring Data REST right now just supports the JPA repositories. There's a fair amount of metadata that has to be sucked in from the repositories to make this work. So at the moment, JPA are the only kinds of repositories that you can export. So this is an example of all you'd have to write to get full CRUD on a person entity. And to export to the REST exporter, you'd need to extend the CRUD repository because it has all the methods that we need to do delete and find one and all that other. So although you can do repositories that are custom and have maybe one method in them or two methods or whatever, you're not going to be able to export those directly to the web because we need those other methods to build up the necessary services to export. So if you extend CRUD repository, these are the methods you're getting. Save, exist, find one, count, deletes of various kinds, so that you don't have to write all those. So then to export these, since we do have all these CRUD methods, we can get put and post as our save. We've got find methods that we can use as a get. We've got the delete, and we use JSON in this as our universal protocol, which you're going to use it anyway in any web application that you build, and it's just kind of a standard way to communicate entities, and so we just don't beat around the bush about it. We're just going to use JSON, and that's what we're going to do. We do add JSON-P support, so if you're using jQuery or something like that and you want to use JSON-P in the exporter, then we do have that. We also have added JSON-P plus error. So generally what happens with your JSON-P request is, if you send your callback equals and give it a JavaScript method to call when it's done, if there's an error, it doesn't return a 200, it returns a 400, 500, whatever. With the JSON-PE support, actually captures a 500 error or a 400 or 409 or whatever the bad error code is, returns a 200 OK, but calls your error callback method with the original status code. So you won't get a 400 or 409 conflict error. You're going to get your error method called with a 409 status code passed in as the first parameter. So that's how that works. Really, this is kind of built around the hate OAS principle, and it's a bad acronym. Everybody acknowledges that, but that's all that we've got right now for a term for it. But basically, it allows discoverability, and that's really kind of the key to it. That all of the resources exported underneath a particular URL are discoverable. From a security standpoint, that may be a little, I don't know if I want to do that or not. That's certainly might be an issue depending on your situation, but as a principle of hate OAS, discoverability is important. You want your client to be able to grab that initial URL and get a list of what resources they can go to next, and those are called links. And so fundamentally in the REST exporter is this idea of linked resources, and you have that in JPA anyway because you have related entities and they are linked, like Michael was talking about with a graph, a relationship, and so we represent relationships between entities as HTTP resources by using links. And of course, they have different meanings in different contexts. But the Atom syndication format has an RFC for a link element. And so we just JSONize that. And so a link in the REST exporter is just a JSON object that has a rel and an href. There's really it's no more complicated than that. And we use the Spring Hate OAS library, which standardizes how you provide resources, and that's something that I'll talk about Thursday and give some examples of. And that's a library that you can implement, or that you can use in your own implementations, and you can return resources, and they'll be rendered in a standard way. So I have already created this sample app, and I'm not going to go through actually building it out, but I did want to show what we've got, kind of the finished product here. So we've got our entity, which is an ad, like a Google ad or something like that, and we've got various properties on here. I'll explain a little bit about what that is in a little bit. We've got a version. We've got some validation going on, make sure things are not null and whatnot. And we've got some timestamps in here, which we've got our pre-persist and pre-update methods so that we can set these. Created and updated timestamps, which we're doing just manually to show how that works. And then we have another entity that has a reference, has a one-to-many reference to these ads. And so that's just our basic domain model that we're going to work with. We have a web initializer to make this web aware. And if you've used the Servlet 3, or if you've not used the Servlet 3 web XML less configuration, this is what it looks like. We're just setting up a root application context with our own configuration, and then we're creating a dispatcher servlet with the REST exporter configuration and just mapping that onto the root. The configuration is pretty simple. We've got our enabled JPA repositories in here. This is nothing that you wouldn't do if you were just writing a normal repository-based application. There's nothing web-specific about this or exporter-specific. This is all your configuration here, your data source. We've got we're just using HSQL, so we've got our basic configuration down here. Pretend like that's not right. That's not here right at the moment. So we do have our exporter configuration that just imports the base configuration class. There's various ways to deploy this, and I'm going to show that on Thursday. This is just one way to go about exposing that. Let's see if we're running here. I don't really remember. Yeah. What I'm doing here real quick that I'm also going to talk more about is I wrote a REST shell for testing resources and this is something that you can use on your own for any REST service that you have. You don't have to be using the REST exporter to use the REST shell. It's just a generic, uses REST template underneath. But it does expect your resources to conform to the Spring Hate OAS way of exposing resources, which is to have an object return and the top level have a property called links. And underneath that would be an array of these rel href objects that listed all of the other links that you have available. So I have the exporter set up underneath this URL here. You can see it's got campaign and ads, and that's just how it exports it directly. And here's what I'm talking about with the format. We've got links, and then we've got a rel, I think. Oops. I don't even know where's the...
Just Command plus or something like
There we go. Okay. The REST shell then has some has some helpers in it. So if you've ever used curl, and you -h content type, blah, blah, blah. So you don't have to worry about any of that with the Rust shell. It's going to assume you're doing JSON back and forth. It's got various helper methods on it: get, put, post, delete. You can set the base URI. And one of the things with links that becomes very important is that you follow a link. And so we have, if you look at our JSON here, we've got this set of links, and so the Rust shell then has a special command that looks in those links and pulls that out and caches that. And now I can reference the rel, so I don't have to know the actual the full HTTP, localhost, whatever. And I can follow the rel and list resources that are also underneath that. So here's what my entity looks like exported. And if we go up one, right, we've got campaign. So let's follow campaign. I've got one in there. And here is how our related property looks. So if you remember from looking at the campaign entity, we've got this list of ads here, and that's represented in this link by this URL right here. So we don't actually inline those when it's related and the entity is being managed by a repository. We put a link in there that you can follow. So if we follow one ads, we've got one in there. And that is the same thing as if we would, let's go back up to history go 1. Okay, that's the same object, right? It's just we're going at it using a different URL. And we can manage these relationships. If we go back to our, we can issue a post to this particular URL that I'm at, this base, so that we can add a relationship, add another one to the list. We can delete specific ones from the list, and we can do all this using HTTP. Question? Yeah. Yep. The question is, can you do the same using the Spring Root shell? The REST shell is based on an extraction from the Root shell that's why it looks very similar, because it's got but the REST shell is a separate project that has these commands implemented for doing the HTTP interactions and for interrogating the responses. So it's built on top of it, but there's more to it. The REST shell itself is on my GitHub right here, and it gives a little quick interaction, what that looks like, what your various commands are and what they do. So if you want to check out the REST shell, you can do that. And if we look on our ads, we see this. We've got a search. So what happens with our finder methods in our repository, and that's one of the big things that we can do. Find by active is true. That's one of our special method names that it just it basically generates a query where active equals true. 5 minutes, okay. So we expose your finder methods that you want exposed. You can turn them off underneath this special search URL. So you'll always have the name of your repository, how it's exported, /search, and then we've got a finder method underneath there, and I have modified my repository with this REST resource annotation, and I've said whenever you export this, use ads rather than what the default, which would just be add lowercase. So I'm making it plural here under this path, and when you export this, search rather than give the full find by active is true. I'm just shortening that to active. Okay, and that runs my finder method and returns a list. Inlined. Now that, oh, yep. This I'm outputting it right here actually. So this is the whole interaction. If you just did this in curl, this is exactly what you'd see. I'm sorry, you have to speak up a little bit there. No, there's no HTML. No, this is raw JSON directly from the server, directly from the controller. How do you construct the what? If you wanted to create a new one, title, and then we've got our location right here, but we've also got a special switch for that. So if we wanted to create that and immediately follow that link to reset our base URI, then we can do that like that. You just embed that JSON directly in the shell. You can also, there's also a switch on that if you want to use if you're doing a post or put, there's a from, and so if you give from my file.json, it'll suck in the JSON, or if you give it a directory name, it will look for every JSON file in that directory and do a post on each individual file, so that you can load data in batch that way. So yeah. Are you able
to apply Spring security to this as well?
Yeah, it's just a normal Spring MVC application. So any bells and whistles you can add to Spring MVC, including Spring Security, you can do. We just don't have an example of how to do that. It's been done with basic authentication. I know somebody set that up, so I haven't really tried anything much more complicated than that. We did want to look at the book, right? You can talk about the book real quick. So that's the Rust shell, and then Mark's going to talk about the Spring Data book that's out now, that you can get a free copy of actually.
Yeah, well, we're at the end. It's time for questions. Just wanted to mention again this book that we all worked quite hard on, and it's the Oprah moment of the conference. Everyone gets one, right? It's not under your seat, but it's in your bag, and you can type this code, and you have to type it during the time window of the conference. Otherwise, the code will expire, and then no free book for you. Oh, the code is in your pamphlet that you should have gotten on the back side. Here, how about someone shout it out and we'll type it. Here, let me get it and we'll put it up. Oh. PRS data, PRSDATA. All uppercase. You got to scream it. Oops. Okay, so there's a GitHub repository as well for the book. That was where I was showing some of those examples from. So there's quite a lot of code there to get started. There's also just started recently a Kickstart GitHub repository on SpringSource that provides small templates to help get you started with the various technologies. So hopefully, we're doing as much as we can and to encourage you guys to try this out. And I really welcome you to grab any of the Spring Data team during the conference and speak to us about things that are on your mind, features you'd like to see going forward. And that's about it. Take questions now. Thanks a lot. Yeah, there's a question in the back there. Aw, is it just for my book or anywhere else? I don't know, try it. Maybe you can get a better book. I heard NoSQL Distilled is pretty good. Not O'Reilly, huh? Yeah, question over here.
So, suppose that we have a project where we're using Spring Data for connecting to MongoDB.
Do we have a project where we're using Spring Data to connect to MongoDB? You mean a sample project?
Yes.
Yeah, there's a sample project. Oh,
Let's suppose we have a project where we have such a situation, and we aren't using any database-specific functionality. What kind of effort would it take to convert that to work with Redis or Neo?
oh, so the question is about moving from one NoSQL store to another. Moving to Redis, I'm sure, would be quite difficult if you have a rich object tree, because you'd have to break things out and have synthetic keys as values in hash tables. So it's almost like saying, you know, how can I build a database off of a hash table, right? You have to have indices, and you'd have to mimic that. So that would be quite difficult. I think, generally speaking, it's probably a fairly difficult proposition to switch. There are things such as transactionality. If you're, you know, have to consider that some NoSQL stores are transactional, some aren't, and you'd have to certainly go back and do the mapping. So I imagine it'd be a fair amount of work. We haven't done a lot. Simple cases with the repository support work very well, but I think at some point in a real project, you're going to start to get very specific functionality, and that's where all the complexity will lie. Okay, one more question, then we can just huddle outside.
I noticed you guys had iBatis, like used to have iBatis, and then it's still kind of...
iBatis? So, right, so what I understand for the iBatis support is Thomas Risberg is the person who's been in closest communication with MyBatis, and that will help maintain that support, but on their website. And so that's how that project is maintained going forward. Under secret, behind the back, we're helping there a little bit. Okay, thanks a lot.